Hello guys, my name is John Michael Reyes and I'm currently a second year BSIT student in Batangas State University, and we are here to discuss the summary of the Chapter 8 Submitting IP Networks. So it is all about the addressing of the IP, or giving the end devices, intermediary devices, and routers or other stuff some IP addresses. And Chapter 8 Submitting IP Networks, and Chapter 8 Section and Objectives. Introduction 8.1, the Network Layer Protocol. Network segmentations. Broadcast domain. Each router interface connects a broadcast domain. Broadcast domain are only propagated within its broadcast domain. In broadcast domain, when you send it in broadcast domain, it somewhat sends all the information to all host devices, and everyone has its own broadcast domain in a topology or system. Then problem with large broadcast domains: slow network operation due to significant amount of broadcast traffic. As you can see, if you have so many end devices and intermediary devices, all it will buffer slow because we have so many of it, because it has more bytes to conquer and read. Then slow device operation because a device must access and process each broadcast packet. As I've said, the reason for submitting it is a solution: reduce the size of the network to create a smaller broadcast domain. Then because each broadcast domain connects to a different router interface, each domain needs its own network address space. Then the process of breaking an address range into smaller address spaces is called subnetting. And network administrators can group devices into subnets that are determined by location, organizational units, or device type. Then after this, you want to inherit your figures. Then octet boundaries. Octet boundaries are somewhat in 8, 16, or 24. Subnets can be created based on octet boundaries. As you can see in here, it is somewhat an octet. This 8-bit in here. Then submitting on the octet boundary, also known as IPv4 classes. Then use the octet boundaries to separate network from the host. As you can see in here, this one separates the network from the host. Then classless subnetting uses address bits to separate network from host, allows more flexibility. Still like this one, as you can see here, there are 126 hosts because of 2, 4, 8, 16, 32, 64, and 128. Then minus 2 for the broadcast address and the other side. Then so only classless subnetting in here, 128. So creating two subnets is somewhat. Subnet mask is applied to 192.168.10.0 creates two equal subnets, each one with 126 hosts. Because the first one is somewhat the 192.168.1.0, then the second one would be the 192.168.1.128. Then submitting formulas, and the submitting formula would be use 2 and 2 raised to n to calculate the subnets. Then use 2 raised to h minus 2 to calculate the host numbers. Then n is the number allocated to the network portion of the address, and h is the number allocated to the host portion of the address. And creating 4 subnets, the subnet mask of /26 to 192.168.1.10.0 creates 4 equal subnets with each one with 62 hosts because it will be divided or plus with 64. The first one is 192.168.10.0. Then the second one would be 192.168.10.64. Then the second one is 192.168.10.128. Then 192.168.10.192. Then after that will be nothing because this plus 64 I think or 254. Then subnetting an a /16 and /8 prefix. Created subnets with a /16 prefix. A subnet mask of 16 applied to 172.16.30 to create a host of 65,534 hosts. A subnet of /18 of 172.16.32.0 creates 4 networks with 16,382 hosts in each network. Then a subnet of /22 applied with 172.16.32.0 creates a 64 network with 1,222 hosts in each subnet. As you can see, if the networks go up, the host goes down. Then creating 100 subnets with each with a 16 prefix /16. A subnet mask of 23 applied to 172.16.32 will create 128 network with 510 hosts in each network. The calculating the host used to 2 raised to h to calculate the number of hosts. Each is the allocated host portion of the addresses. Then creating 1000 subnets with a /8 prefix. A subnet mask of 18 applied to 20.0.0.0 creates 1,224 network with 16,382 hosts in each network. And after that, subnetting to meet requirements. Subnetting based on the host requirements to consider when planning subnets: the number of host address required and the individual subnets needed. Then after that, the subnetting based on network requirements, the IP range. Then things of a 7 department where each department must have its own subnet. Then host per subnet. Then while secondary is also important. Then network requirement example. These are the range. As you can see, 7 subnets must be created. Each department will have no more than 29 hosts. Then a subnet of 27/27 applied to 200.42.98.0/24 creates 8 networks with 30 hosts in each network. Then as you can see, it accommodates the requirements. Then benefits of BLSM. Traditional subnetting rules address subnetting based on classes is not flexible, result in wasted addresses. BLSM, by varying the mask of administrator, has more control, less waste than basic BLSM. A subnet mask of 30 applied to 200.42.98 creates a network with 2 hosts in each network. The small to medium-sized business network, then given a set of requirements, implement BLSM addressing scheme to provide connectivity to end user in a small to medium-sized network. Explain designs consideration for implementing IPv6 in a business network. As you can see in this chapter 8, it is the most important part is the VLSM, because in the VLSM you can accommodate, or in VLSM the IP address would be fine or in the order because it would be entangled with each other, and you will maximize the network addresses in the host portion for it. Then that's all for chapter 8.